Hi guys, so question 9, this is an integration by substitution. They give us the substitution, which is nice, and it is, okay, well it's this. So we're going to use this substitution. So we're going to say instead of u, well hang on, let me write this out here. It's sine x cos x over sine squared x minus sine x minus 2 dx with a fraction. Okay, so over the side we say let u equal sine x, which they've given us. So I can say du dx is equal to cos x. We differentiate it. Then I can do this thing where I can say I can cross multiply this and say du over cos x is equal to dx. So that's multiplying across by dx, dividing by cos x. Yes, I'm aware it's not exactly multiplying across, but that's just kind of what we say to make our lives more easy. Okay, so u is sine x. So this becomes u, because u is sine x. I'm going to leave the cos x here for a second. That's cos x. This is now u squared. This is minus u minus 2, and the dx is du over cos x, and these cos x's cancel nicely, and that's what we kind of expect and hope for in a substitution question. Okay, next thing, now we're dealt with this, u over u squared minus u minus 2 du. That's not an easy integral. We've got a bit of a problem here. We can't integrate it the normal way. We can't use substitution again, although actually we could try, but well, no, it wouldn't work out very nicely. The way we're going to have to do this is we have to factorize the bottom and then use partial fractions. So this factorized is u minus 2 times u plus 1. Hopefully, guys, you can factorize a quadratic, and it's this du. But we know that u over u minus 2 times u plus 1 can be written as a over u minus 2 plus b over u plus 1. This is partial fractions. Again, guys, if you don't know what I'm doing here, I suggest you go and watch my video on this. But I can then say this is equal to u minus 2 times u plus 1. I get my common denominator at the bottom. And then this a is multiplied by u plus 1, and b is multiplied by u minus 2. And if this is the case, then because this is equal to this and their denominators are the same, then u has to equal this, a times u plus 1 plus b times u minus 2. Multiply out, u is equal to a u plus a plus b u minus 2b. Now, the coefficients of u must be equal, so 1 must equal a plus b, and the coefficients of, well, the constants must equal, which means 0, because there's 0 here on the left, has to equal a minus 2b. Then I can say, well, do this however you want, but I am going to say a is equal to 1 minus b from this. So 0 equals, instead of a, I'm going to do 1 minus b from this equation. So 1 minus b minus 2b. I'll do 3b equals 1. B is equal to a third. If b is equal to a third, I'm going to say, therefore, a is equal to 2/3, because 1/3 plus 2/3 equals 1. So A is equal to 2/3. Okay, now I have this. Sorry, I was up here, but now I've said that this is equal to this. So I'm gonna actually say that, if you're okay with this, guys, I'm just gonna move this over here, and I'm gonna draw a straight line down, and I'm gonna go back here. Okay, therefore, I'm trying to find now the integral of a over u minus 2, which is 1/3 over u minus 2, plus b, hang on, sorry, a was 2/3. So it's 2/3. And by the way, guys, I can take out the 2/3 here if you like. So I'll take out the 2/3, integral of 1 over u minus 2, plus 1/3 the integral. Yes, it's the integral of the whole thing, but the integral of the whole thing is the integral of this plus the integral of this. So it's 1/3 times 1 over u plus 1. The integral, that is, that's du, and that's du. So this is equal to 2/3 the integral of this. Now the integral of this is ln of mod u minus 2 plus 1/3 ln mod u plus 1. There we go. That's the integral. But I need to finish, because remember, u equals sine x from the very beginning, and we have to write it in terms of x. Therefore, the integral equals 2/3 ln of sine x minus 2 plus 1/3. Guys, what did I forget? I forgot to put a plus c at the end. Do not forget your plus c. So plus, hang on, that looked like not a plus. Hang on, this is plus c. So it's plus 1/3 ln of sine x plus 1 plus c. And that's it. Okay, obviously that's a long question, but it is a question 9, and it's worth 7 marks. So definitely not easy, not super impossible, but it's a long question, and one you have to obviously be very careful with. Okay, see you for question 10.